So let's now go ahead and look at our homework. 2-5. What questions do we have to work through and look at? Number 5? Sure. Okay. We've got plenty of time to go through as many of these as we need to.
11, 12, and 13.
Okay, 11, 12, and 13.
Can we do number 8 too?
Sure, yep, we can add on number 8 as well.
3, 9, and 10.
Okay, 9 and 10.
And 3 also.
And 3, sure. Okay, do we have some more to look at? We're going to go ahead and start with these, and we can add more to the list as well. On these, I'm not going to solve all of them out completely, but I'm going to make sure we spend the time that we need to see how to set them up, to get to the equation to solve. So if a lot of them are the same, I'll solve maybe the first one through, and then the others I'll set up the equations and leave it for you to solve the equation. So we're going to start with question number 3. Now, for question number 3, we're going to have to talk about the difference between, let me adjust the focus a bit here. We're going to have to talk about the difference between supplement and complement. So what we've got on question number 3 is we want to find the angle. Now, what does that mean? That means we want to solve for x. Okay, when it says find the angle, that simply means solve it for the value of x. So we want to find the angle such that the difference between the supplement and 3 times its complement is 50 degrees. Now remember, that is means equal. So let's write this out in words. Then we'll make sure we understand what the supplement and the complement are. We'll plug them back in, and then we'll solve it. So we want to find the measure of an angle such that the difference between the supplement and 3 times its complement, so that's going to be the supplement minus 3 times the complement, is means equals again, 50 degrees. So that's going to equal our 50 there. Okay. Now, we need to remember what the supplement and the complement are. So these are definitions. So what's our supplement? Well, the supplement is 180 minus x. And the complement is 90 minus x. Okay, so those are just our definitions. Supplement is 180 minus x, and the complement is going to be 90 minus x. So now we can rewrite it, and we can get our equation. So if we rewrite it, we've got the supplement, which is 180 minus x there. That represents your supplement, minus 3, and use parentheses. What's our complement? 90 minus x, and that difference then equals what? Equals 50. Do you see how I set it up? So I read it through. I went back, and you can either remember or go back and look up the definition of the supplement and the complement. We wrote it out in words. We plugged our values in, or our information in for the supplement and the complement. We wrote our equation, and then you should be able to solve it. Now, one thing when you solve it, remember, this -3 is going to be distributed through. So you got to make sure you distribute that -3 through. You're going to solve it, and that's going to give you x, and that's going to give you your final answer. Okay, so I'm not going to finish this out completely, because you should be able to solve this equation on your own. Okay, so just distribute that -3 through, combine like terms, solve for the variable x. Question 5. Okay, so question 5. We're going to be talking about consecutive odd integers. Now, what do we know about regular just consecutive integers? Well, consecutive integers are back-to-back numbers, right? Like in your textbook, back-to-back pages. So they have a difference of 1. What about even or odd consecutive integers? They have a difference of 2. That's like house numbers. So when we look at these, we need to make sure we see if it's even, odd, or if it's just plain a consecutive integer. So those are keywords we need to look for. And then we need to figure out how many of these we need. We're going to read it through first. Then we're going to write our equation, or our equation up with words, then plug in our variables, and then finally solve it. So, if the first and the third of 3 consecutive odd integers are added together, the result is 69 less than 5 times the second integer. Find the third integer. So first off, what do we know? Well, first thing we need to understand and write down is how many integers we need. We need 3 of them, okay? And they are, in this case, odd. So they're going to have a gap of 2. So make sure you look for those words. So these are odd consecutive integers, and we need 3 of them. So let's go ahead and write that down. So we need odd integers. Now the first integer is always x. These are odd, so what's our gap? Our gap is 2. So we're going to add 2 every time. And we need 3 of them. So that's x for the first one, x plus 2 for the second one, and x plus 4 for the third one. Is everyone okay with how I did that? Now, if these were just consecutive integers, what would they be? If it was just consecutive integers, it would be x, x plus 1, and x plus 2. But these are odd, so they're going to have a gap of 2. So make sure you watch for words like that. And we need 3 of them, because that's what that first sentence says. Then if we go back and we read that first fragment here, it says if the first and the third of 3 consecutive odd integers are added together. So we need the first and the third. So we're going to add those together. So those are going to be added together. The result is, that means equals, 69 less than 5 times the second integer. So we need 5 times the second integer. And then what about that 69? It says less. So that's going to be subtracted off from the end. So we need to make sure we read it. Okay, make sure on that last part, the result is 69 less. Okay, so that's going to be taken away from the end. And we are taking that away from 5 times the second integer. Is everyone okay with how I set that up? You see where I got all the pieces and the words there. Make sure you're careful, and that 69 is negative, and it needs to go on the end because you're subtracting it away. It's less than. Now let's go ahead and fill it in. First one is x. Third one is going to be x plus 4. Then we've got 5 times, we'll go ahead and plug in our second one. We're going to have to use parentheses here. What's our second one? X plus 2. I'm going to leave this for you to finish. and go ahead and find all three integers. We want the third one. That's what we want. But to get that, we've got to get the other two as well. So go ahead and find all three integers and highlight or circle the third one. So find all three integers and circle the third one. Because that's what they want. Okay, they want that third integer. So is everyone okay with that? So you distribute through. Yeah, I don't want to spend a whole bunch of time solving these out because we should be able to solve equations. The tricky part is setting them up. So when I solve this, what would I do? I would find x. Okay, and then what am I going to do for my next one? Let's say x was, I don't know, let's pick an odd number. How about x was 9? Okay, if x is 9, the next one would be 11, and the next one would be what? 13. We want the 13. Okay, does that make sense on how to do that? Yep, so just find that first one, add 2 to get the second one, and add 2 more again to get the third one. Yeah, 9's not going to be the answer, I can tell you that, I don't think. But solve it out your own and see. Because I can't remember what the answer is, but you've got the equation. Distribute that 5 through and solve it. Question number 8. So this is going to be a triangle problem. What do we know about a triangle? Well, we know all the angles in a triangle. There's 3 of them. They add up to give me 108. So that's going to come into play there. It's a problem that involves a total. Some of these problems that have a total might be things like the number of wins and losses of a team. Might be things like Republicans and Democrats in Congress. Okay, anytime you have 2 or 3 things add together to give you a total. In this case, we're looking at a triangle, and the 3 angles add together to give you that 108. So it says the sum of the measures of the angles of any triangle is 180 degrees. In triangle ABC, angles A and B have the same measure. While the measure of angle C is 30 degrees larger than each of A and B. What are the measures of the 3 angles? So we've got our 3 angles. So let's go ahead now and label them as A, B, and C. Okay, and what do we know? We know A and B are the same. And what do we know about angle C? So these are the same here. What do we know about angle C? Well, angle C is going to be 30 degrees larger than each of angles A and B. Okay, so that would be what? Doesn't matter which one we use. How about we use C is going to equal to A plus 30. And we know that A and B are the same, so we're going to go ahead and call A X, and B is going to equal what? A, because these are the same, right? Now we can convert this all to the variables. So A is X, B is X, and C, when we convert, is going to be X plus 30. And then now what do we know for our equation? What do we need to get for our equation? Well, we need to go ahead and write these equaling what? They add together and they give you 180. So we know that A plus B plus C is going to be what? 180. Now we can fill it in. So A is x, B is also x, and C is x plus 30. And that equals now 180, doesn't it? Are you with me so far there? Okay. Now what are we going to do? Well, now we can go ahead and solve it. Okay. And then once we solve it, what do we get? We get x. So that's going to go here. That's going to be A. Now B is also going to be what? The same number. And what about C? That's going to be whatever number you find, add what? 30 to it. And then those should all add up to give you what? They should add up to give you 180. Okay, and they will. So that's how you'll solve that. And if there's any of these you really want me to solve completely, just say something and I can do that. But I really want to leave at least something for you to do in your homework. And I know where we struggle the most at is just making sure that we set them up. Because that's always the struggle, is how do we set these up? Okay, question 9. I'll shut the door so it's a little bit quieter back there. Do you need the homework packet, maybe? Chapter 2? Got one around. I'll find it. I've got an extra one somewhere. Welcome to your homework packet for chapter 2. So we were looking now at question number 9. Question number 9, again, is a supplement and complement problem. So we want to find the measure of an angle. That means we are solving for x, whose supplement is 6 times the measure of its complement. So remember that is means equals. Okay, and let's see. Measure of its complement here, that means equals. So we got that it's there, okay, or is, in some cases it's written like that, result as, it means they're going to equal. So what do we have? We have the supplement, and it says 6 times the complement. So that means we've got our supplement, and that's going to equal 6 times the complement. And we're in section 2.5. So what are we going to now do? We know the supplement is 180 minus x, and the complement is 90 minus x. Remember, those are our definitions again. So just make sure you have them somewhere. Those are the only ones we use over and over again. And so the supplement is 180 minus x. We've got the 6, and we'll bring down our complement, which is 90 minus x there. Is everyone okay with how I set that one up? So we went through, we looked at what we've got. They are supposed to equal each other. Why do they equal each other? We've got find the measure of an angle. You supplement is. Remember that is means equals. Okay? 6 times the measure of its complement. So is, result is, things like that, that means equals. Okay? So they're going to equal. And now you just distribute that 6 through. And you solve it for x. And x is going to be your final answer. And now let's move on to question 10. Another supplement complement problem. Find the measure of an angle if its supplement measures. Now, measures can also mean equal. Okay, so if it measures, that can also mean equals here. 58 more than twice its complement. So find the measure of an angle. That tells us we're solving for x. If its supplement measures means equals, 58 more than twice its complement. So we've got the supplement. Measures, in this case, that measures means equals. 58 more than twice its complement. So we need twice the complement. Plus that 58. What do we know about the supplement? 180 minus x. What do we know about the complement? 90 minus x. We fill it in. And now we have an equation that you can solve. Is everyone okay with how I did that now? Again, if you want me to, I can work it out all the way, but I really want to leave something for you to do. And I know where we probably struggle at is how to actually get the equation. More so than solving it. Hopefully you don't have a lot of trouble solving these. Most students generally don't. It's in the setup. How do we get to that point? So that's why we're spending a lot of extra time just talking about the words, what they mean, how the pieces go together. Okay, so pennies are packaged 50 in a roll. A mother gave her son 95 pennies for his bank and had 5 pennies left over. How many pennies did she use? So how many rolls of pennies did she use? Okay, well, what do we know? We know that each roll has how many pennies? 50. Okay, so each roll has 50 pennies. So if we look at each roll, that roll is going to equal 50 times the number of pennies that we have. And you could even do this one without an equation. I'm going to use an equation just so you see how we can actually set that up and use it. We're going to call the pennies x. Okay, so if I rewrite that, that means the rolls of pennies, each roll of pennies is going to be 50x, because x is going to equal the number of pennies. So each roll has 50 pennies, and we're going to call x, the number of pennies that we have here. Now, what are we going to look at next? Well, we need to figure out what's happening. So a mother gave her son 95 pennies for his bank, and he had 5 pennies left over. Okay, so how many rolls of pennies did she use? So they're packaged in 50. Mother gave her son 95 pennies for his bank, and he had 5 pennies left over. So we need to figure out how many pennies we're going to use. So how many total pennies do we have? Well, she gave him 95, right? And then he had 5 left over. So that means he's got a total of how many pennies? 100, right? So there's 100 pennies total. Now, we know that 100 pennies, we're going to figure out how many rolls we need, and each roll is going to equal what? 50x, okay? And then we just divide by our 50. And how many rolls of pennies do we need? 2. So that means we have 2 rolls of pennies. Okay? Is everyone okay with how I did that? So, gave her son 95 pennies from the bank, 5 left over. Okay? So that means 100 pennies total. We labeled each roll as 50x because there's 50 pennies in a roll. X is going to be, X should be the number, well, yeah, X is not going to be pennies, it should be rolls. I should rewrite this a little bit better, but you can almost do this one without even an equation. Sorry, this should be pennies here. You could do this without an equation. I'm just doing an equation so you see what happens. So we've got pennies here, 50x, okay, worked it through, and we ended up with x, which is then the 2 rolls. So we need 2 rolls of pennies, and you could have done that without an equation, right? You could have just said, I got 100 pennies, divide that by 2, divide that by 50, because 50 pennies were in a roll, end up with 2 rolls. So you could do this one without an equation. But I set up an equation just so you'd kind of see how it can be done. Question 12. This is another triangle problem. And again, we know that in a triangle, all of those angles are going to add up to give you what? They're all going to add up to give you 180 degrees. So this one's going to be very, very similar to the triangle problem we did a few minutes ago on question 8. So question 12, the sum of the measures of any triangle is 180 degrees. In triangle ABC, A and B, they have the same measure. Bless you. While angle C is 12 degrees larger than each of the other 2 angles. Find the measure of angle C. I would go ahead and just get all 3 of them and then just circle angle C. If you forget to circle it, if you just find all 3, that's fine too. But as long as somewhere you end up with angle C. So let's see what we know. We know we're going to need our 3 angles, A, B, and C. And we know A and B are the same. So that's the given part there, is that A and B are the same. And we also know a little bit about C. It says C is 12 degrees larger than each of the other 2 angles. So C is going to be 12 degrees larger than either one. So we'll say C is going to be A plus 12. And we know that A and B are the same, so A equals B. And which one do we not know? A. So we'll call A the X. And now we can rewrite this as X for A. B is also going to be X. And C is going to be X plus 12. Is everyone okay with how we set those up? Because A and B are the same, right? So one we call X, the other one is linked. So then they're the same. And it says C is 12 more than each of the others. So either one. So we'll just call it A. We'll plug in X for our A there. And now what's our equation? It's a total. And we know in any triangle, A plus B plus C equals 180. So we know A is X. B is also X. And C is X plus 12. So now we have that part. And now I think you can finish it from here. Not be hopefully that difficult to finish out. You'll get an answer. Now, it will be a whole number, I'll tell you that. So if you end up with a decimal, you made a mistake. On all these angle problems, you're not going to end up with a decimal. It's going to be a whole number. And X is going to be positive. If you end up being a negative number in these angles, you made a mistake. These angles are always going to be positive. So if you end up with a decimal or a negative number, you already know that you made a mistake. We've got a couple more to look at, and then we can add more if we need to. So that was 12. We asked about 13, which is a mixture type of problem. And we're going to see how these relate. Okay, so 13. If you go to the paint store and you buy paint, paint's always white, right? And then you go up and you say, okay, I want this color. So then they take that white can, they open it up, and they add the color. So most of it's white, a little bit of color that they add to get the color that you want. But it's two things, the white plus that little bit of colorant that they add. So a paint mixture contains 39 gallons of base for every 1 gallon of color. In 600 gallons of paint, how many gallons of color are there? So when we look at this, we need to figure out which one's going to be larger. But when we think about it, we know there's going to be a lot more of that white paint than the color, right? If you go to the paint store, they only add a little bit of colorant to get the color that you want. Then they mix it all up. So it's going to be much, much more. And what are we looking at? We're looking at two different things. We're looking at the base white and the color. So those are going to be our two components. So that base white and the color. So we've got the base and we've got the color. Now, how do these relate to each other? Well, the base is going to have 39 gallons for every 1 gallon of color. Let me move this down here. Sorry about that. Focus back hopefully a second here. All right, so fix that. Okay, there. So we need the base and we need the color. Get that so let me make it a manual focus here. I think it got stuck. Okay. Well, let me just adjust the focus and then we'll go back and look here again. So this is what we've got. So we've got the base and we've got the color. We know there's going to be a lot more of the base than the color. 39 times as much. So the base is going to be 39 times the color. And remember, one of these we don't know, so we're going to call X the color. And now when we rewrite this, we know our base is going to be 39X, and we know our colorant is unknown, that's X. So that's what we've got. Now, we do need a total. And so what do we know our total is? Well, that's 600, and that total is the base plus the color. And that equals 600. So the base is 39x. The colorant is x, and that equals now the 600. And you should be able to finish it from there. Just add them together and divide. And what are we trying to find? Well, we're trying to find how many gallons of color. So all you need to do is solve it, and x is going to be the color, and that'll be your answer. You can find the base if you want to as well, but all you really need to find is the color to answer the question. And these are ratioed together. It's 39 to 1. So that means 39 times as much base as color. And again, think about going to the paint store. All the paint on the shelves is white. You take it up, you say, I want this tone of gray. They open it up, they plug it into the machine, and it drops just a little bit of colorant down. Then they mix it up, and you get your color. Are there any others to ask about? So I don't think there's any more on the list, but we can add more if we need to. Are there any others that you'd like me to help set up? You've got plenty of time to look at these. Any more of them? Any others? Okay, I think we did a couple of each type. So let's now go ahead and just barely begin 2-6, and then we'll take a short break. So we're now just going to barely begin looking at 2.6. And 2.6 is using formulas. And this is actually an easier section, I think, than the last one. So whenever we need a formula, we can always go to the back cover of our textbook. So whenever we need a formula for area, perimeter, a rectangle, a triangle, maybe we want the diameter or the circumference of a circle, they're going to be in the back cover. So we're going to be using the back cover quite a bit for these different formulas. Now, before we start plugging numbers in and evaluating down the formulas, let's learn how to solve them for a specific variable. And these are what are called literal equations. And literal equations are just quite simply equations that have more than one variable. So we're going to be working in this section with literal equations. And all the formulas are going to be literal equations. And that just means that they have more than one variable. Okay? Now, we can either plug numbers in, if we need to solve for a specific one, or we can solve for a variable itself. So let's go ahead and solve for different variables, and then we'll learn how to use them with applications. So I'm going to give you a literal equation, and you're going to have to solve it for a specific variable. So we're going to try and solve this, and I have to tell you what variable to solve for. So here's the directions. We're going to go ahead and solve this for z. And here's our literal equation. A plus z equals 9. Make sure you know that's an A there. Well, let's make it an 8 so we don't get confused and combine an accent together with the 8. So let's say A plus z equals 8 in this case. So I could use a 9, but I'm afraid we might get the 9 mixed up with the 8. So we'll use an 8. Now, when we solve these, we need to get the variable that we want by itself. So when we solved equation, what did that mean? When we solved for x, we got the x on the left-hand side. Right? Remember that? Same concept here. Everything's the same, except we've got numbers and variables all together. We want to solve for z. So that means that we want this z to be by itself on the left. Now, how does that a relate to that z? Well, it relates to that z with addition. So we're going to get rid of it by subtracting it off. And then what's going to be left over? What's going to be left over is z, and that's going to equal 8 minus a. And that's what we want for our answer, because we want to end up with z by itself in this case. We cannot combine the 8 and the a together. They're separate. One's a letter, one's a number. We're going to do a lot of these, and they're really not difficult once you see what to do. And I always like to, whatever variable I'm solving for, I always like to put a box around it. That way I know where it's at. And that green box needs to be by itself. So let's try another one. And let's go ahead and solve this one for a. And here's our equation. P equals a plus b plus c. And we are going to be trying to solve this for the variable a. So the first thing we want to do is we want to find it. And we're going to put a box around it. So we've now put a box around that a. Now I want that a to be all by itself. And we'll put it on the left as well at the end. So I want that a to be by itself. So let's go ahead and move things around so that we can get the a all by itself. Well, we want it by itself, so let's move that b over. And we'll move the c over. We can do two things at once here. So those will be moving over. And then that gives you p minus c minus b on the left. And what does that equal? That equals a. Okay, so just move them over. Now, when we answer our questions, we normally want the variable on the left, so we can switch it around. And if it ever comes out to be on the right, you can just switch it to the left. So I could just move that around, and that gives you a equals now p minus c minus b. And that is what we want, because we wanted to solve for what variable? We wanted to solve that for a. That's what we did. When we solve, what does it mean? It means you get that variable that you want all by itself. We'll do one more, and then we'll take a short break. Let's do one with a number in it now. Equaling a number. Okay, how about we try to solve this for, doesn't matter what variable. How about we try to solve this one for b? And how about we use a equals 3bc. Again, what is our goal? Our goal is going to be to get that b by itself. So we're going to go ahead and put a box around the b. So there's the b all by itself. Now, we need to think about how they relate. There's no addition in this at all, is there? Okay, how does the 3, the b, and the c all go together? There's no addition. They go together by multiplication. Because it's 3bc. They're all multiplied together. So what operation undoes that multiplication? Division. So we need to get rid of that 3. So we're going to divide by 3 on both sides. We need to get rid of that c as well, because remember, we want the b by itself. So we're going to divide both sides by that 3 and also that c. That way they cancel. And that leaves us then with a over 3c equals b. Now, what variable are we solving for? B. Is b by itself? Yes. Now, when we rewrite it, we want to make sure that b is on the left, so switch them around. That way b is on the left, and that gives you b equals a over 3c. So once you kind of see how they work, they're not that difficult. Sometimes students tend to make them more difficult because of the extra variables. But it's just same as before, using opposites. Opposite of addition is subtraction. Opposite of multiplication is division. So why don't we now go ahead and take a short break, and we'll meet back here at, let's say, 9:30. So let's meet back here at 9:30, and then we'll go ahead and finish up this section.